Yeah. Now it should work.
Okay. Sorry, I was muted. I think I should start again. My outline of this presentation is first I will discuss about the motivation of this work, and later I will discuss a brief introduction, and further what are our findings, some conclusion, and very important references. So basically, this work is we conducted a case study on an autonomous OEM, and nowadays we all know that the machine learning is a part of everybody's life. It is there in everyone's equipments, and we have the autonomous vehicles also. So it is important to investigate the workflow of the development of these ML driven products. So, and we also found that based on our investigation, there is no scientific evidence that is there which can explore the alignment between the classical software development phase and the machine learning based workflow. So based to investigate this, we conducted this case study. We took interview of different engineers who are directly involved in the development of image intensive perception system. So we all knew that the classical software development product was based on the classical V model, but recently it is shifted towards the safe scaled agile framework. And we also know that the machine learning workflow follows the classical data science process, in which we just collect data, we annotate data based on our requirements. Then further we train the data, we get some performance, and if we are not getting required performances, we retrain the data, we recollect the data based on our requirements. So we are investigating all these aspects in this case study. So basically, we conducted a case study, as I already discussed, and the people the people who are involved in these interviews are the engineers who developed this image intensive perception system for the autonomous vehicle, and they used the camera was involved was fisheye camera for low speed maneuvering scenarios. And there is no image detection or object detection and image recognition or semantic segmentation method is not there for this fisheye camera. So it is important to investigate this pipeline. So okay, so to investigate this, we framed 3 research queries and 3 sub research queries. First, the first research queries was based on the data collection process. I mean, how the data collection planned, how it get executed, how they evaluate that they have collected the sufficient data. The second research queries was based on how they split data, how they define that this is the correct way of splitting data to assure the production quality. The third research query was that what are the different characteristics of a good architecture. I mean, how the model architect, how they define a good model, how they process the how they execute the training process of a model, how they quantify the performance of a model based on this different KPIs. So we are investigating all the 6 queries in this case studies. So based on our interview, we found that this is the stack development at the OEM. And for example, there is a function owner. Function owner knows that this is the requirement. He or she, the function owner, sent the requirement to one of the supplier team, and they also send the requirements to the function developer team in the same company. And the supplier team, based on the requirement, they collect the data, and they follow the data collection process based on different geographical position, and based on different season weather conditions, all the things. They also try to cover all the rare case scenarios. They also try to achieve the corner cases. So it's a very tedious process and very long-term process for them. Similarly, the function developer also collect the data. They have the data collection team. Their team, they also collect the data based on the similar process. Later, after collecting data, the supplier team train a model based on their collected data, Similarly, function developer also train a different model. They test their model, their existing benchmark techniques. They also try some state-of-the-art methods. And the supplier team also share their trained model with the function developer, so the function developer can motivate themselves, and so that they can compare the performance of different models. So after this model training completed, the function is shared with the testing and validation team. The testing team tests the developed function based on different security and safety issues. They have some ethical norms also. So after this, all this process completed, the developed software component deployed into the vehicle. So this is the stack development of this of the OEM. So basically, we are also trying to overlap the different classical software development workflow with the machine learning workflow. So as we can see that the classical V model has different states. So up to 4 states, the development, the software development along with the testing process occurs, and later they switch into the calibration and optimization. So whereas in the software development workflow, based on there is no specific functional requirement, but there are some non-functional requirement as suggested by the Habib in the previous slides. So that they collect data, they perform some annotations, they train the model. So this is the classical different hierarchy of V model and the model. So we are trying to align these two different phases. So this is the table that we got from our investigation. That in the first column we can see that different phases of machine learning. What are the different activities? We also provided different recommended practice. What kind of activity? What kind of practice should be recommended based on different activities? And what are the reasons? And finally, which of the machine learning is overlap with the classical V model workflow? So as we can see that in the data collection planning activity, the planning activity is mainly based on the different geographical position, different weather conditions and surfaces. They try to tackle all the obstacles. They also try to cover all the spread. They also take care of the spread of data. So and based on that, they also try to assure that there is no data leakage while collecting this. And we think that this data collection planning activities is overlap with the system design of the V model. In the data collection execution phase, they collected data. They try to cover all the scenarios. They also try to achieve the high quality images. But there is one tricky thing. They also manually age the camera so that the vehicle can detect the object when the vehicle got old. So they have this thing also. And we think this data collection execution phase is overlapping with the system design phase of the V model. So in the cleaning and annotation phase, they organize the data and they remove the noise and they categorize them, and they actually collect the data on different phases. They categorize the images based on different scenarios. They annotate the frames based on scenarios, and based on this, we think that this phase is overlap with the system design phase. Similarly, model architecting, they extract the relevant features. They remove some of the redundant features. They if there is because it is difficult to capture all the corner cases. So they also try to augment the corner cases scenarios in the data set. So we think this overlap with the implementation and unit testing phase of the V model. So similarly, they try to train the different models in parallel. They also try the state-of-the-art or benchmark methods based on the similar problems. They try to track the performance. They monitor the different threats, and they select one of the model and try to tune them based on the required rating or required performance of the model. And we also think that this training model is overlapped with the implementation and unit testing of the V model. And in the performance evaluation phase, they select different KPIs based on requirements. They compare different KPIs. Of course, they try to tune the model and try to achieve the optimal KPI. And in the testing and validation, they execute all the test cases. They've also followed the legal requirements. They have some specific threshold rating from the function owner. They try to achieve that. The function owner also have their own functional requirement. They also try to achieve that. So so we are thinking that this testing and validation phase is overlapping with the system testing phase of the V model. And in the model deployment, they track all the actions in the scenarios. They also note the deviation in the test in all cases, so that in future they can validate those things. And we are thinking that this model deployment phase is overlapping with the acceptance testing of the V model. So based on our finding, we just concluding the research, the address of those research queries, the justification of those research queries. The first research queries was about the data collection and validation and everything. So we think that the data collection process was actually thoroughly planned based on different functional requirement. They followed the guidelines based on the weather conditions and geographical location, but somehow they also they are a bit flexible because they also have to cover all possible scenarios. So if you want to cover all possible scenarios, you have to be a bit flexible. And they also taking care of the driver and the team member who was collecting the data. So it's better to be flexible at some time. And and data collection, there was there are two teams who are collected data, the original OEM and the supplier team for the same function development. And the OEM team also perform, I already mentioned that they also perform a data splitting method based on the requirement that they have. And if they don't have any specific kind of features, so they add some proxy features so that for example, I do have an example. For example, if I am driving my car into a tunnel, and so my car is detecting object in the darker space. Suddenly, I'm just getting outside of the tunnel. So my car is on the lighter space. So this light transition is very difficult for the system to get the real object to identify the real object. So this kind of rare situations are also added, and they split the data into, as this is the classical thing, they split the data into train and validation sets based on different criteria. For the third research query, both the supplier and the OEM they tried very simple and fast learning model for the first attempt, and they initially tried the classical neural network and deep neural network and try to optimize them using hyperparameter tuning. They also there are some other teams in the OEM function developer who conducted experiments on some of the baseline methods, so that if the baseline methods achieve better performance compared to the other methods, so they will take them. And they also try to reduce the size of the train model, because in the vehicle there is a very limited computing. So they want to deploy that train model in the vehicle, because in the target deployment they don't have sufficient computing resources. So that is their objective. And for all those three research queries, we believe that the team trains a network basically from scratch based on it includes a lot of manual work, and they also take help from multiple environment. And OEM also perform a lot of manual work to analyze the training process. The training process is very time consuming for both the OEM and the supplier. And when the KPI reaches up to the required function owner's requirement, then they stop the training. And if the KPI stop, then they also stop the training. So, okay. So the final, the last few things that we got, that the team, the team organization KPI they actually organize the KPI into three different levels. First, the pixel level, and second, the occupancy grid level. The third is the sensor fusion level. They mainly measure the IOU for the pixel level. Then the KPI for simulation, and they also try to minimize the false positive rate. They backtrack if any phases, if any of the poor performance is coming from any of the phases, they backtrack to that phase, and they reevaluate. They add. So they try to fix the bug or try to retrain the model, then so that they can achieve the optimal results. So they have different teams that only examines the performance of the model at different KPI levels, and they also focus on the true positive rate when the drivers in the target dummy. I mean, they have a target dummy track, so they also in that track they try to analyze the true positive rates, true positive rate. So based on our case study, we have some conclusion. So we found that that the fisheye camera for autonomous system is not well supported for machine learning research, and the safe framework for autonomic development process is not so good fit for this machine learning development workflow. And the team mainly focus on the data collection. Why data collection? Because data collection is very important. They have to cover all the scenarios, all the corner cases, everything. And the model development phase, because model development phase is like the most time-consuming phase for the machine learning-driven model. So these are the some important references of our.
Thank you.